I've talked about internal energy. Okay, internal energy as the sum of the kinetic and potential energy of the molecules in a material or gas. And I've talked about the idea of heat. I've talked about how heat is really the sum of the kinetic and potential energies of the particles in a body. So it looks like heat is really the same as internal energy. Let me take a look at this idea a bit further. Now, so I've talked about internal energy. Internal energy, that would be U as the sum of the kinetic and potential energies of the particles in the body. I've talked about heat, the idea of heat. Now in physics, we often use Q to represent heat. Now I want to ask the question now, is heat the same as potential energy, as internal energy? If I heat an object, can be a solid or a gas, right? The particles inside move faster, move further apart, so internal energy increases. Can I also say that the heat increases, or that there is more heat in the body? Well, in everyday usage, yes. We don't. In fact, we will never say. We would never use the word internal energy. We would always use heat, right? If something is hotter, there is more heat in the object. If I feel hotter, there is more heat in my body. Well, okay. Sometimes we also say internal energy, but maybe not. We don't exactly mean it in this way. But in physics, we make a distinction between internal energy and heat. So let me explain the difference. Let's say I have two bodies, maybe even the same identical body, and let's say one is hotter than the others. So okay, let me write down a temperature. Let's say this is 25 degrees Celsius at room temperature, and let's say that one I've just put it in a bucket of boiling water and just taken it out. Maybe it's about 95 degrees Celsius. So this one is really hot, this one is cool. Okay, so clearly this one has more heat, right, in everyday usage. Now in physics, I would say that this one has more internal energy, this one has less. Now I wouldn't call that heat. Now when do I use the word heat? I use the word heat when I do this. When I put this one, put this body in contact with this. Right? Let's say I move the two so that they touch. Okay, so I'll try and draw that. So this body here, okay, that is now touching this other body. So they're not touching. So when they touch, this is hot, right? This is hot, this is cold. Hot, this is cold. You know what happens when hot meets cold? The cold gets warmer and the hot gets cooler. Energy, heat flows from hot to cold, right? Heat flows from hot to cold. And that is an acceptable everyday use of the word heat, I'm sure. So heat flows from hot to cold. Now in physics, we define heat specifically as the transfer of energy. It is defined as the transfer of energy from a hotter to a cooler body. So that's how we use heat in physics. Now the important word, the key word here is transfer. We don't use heat for the energy that's already inside a body, all right, the Ke and the Pe that's already inside a body. No matter how hot it is, we don't say that there is more heat in the body, not in physics. Okay, in physics we use the word heat with a more specific meaning. All right, we use it as to mean a transfer of energy. So when energy flows from hot to cold, the amount of energy that flowed, the amount of energy that's transferred, is called the heat. So that's what heat means in physics. So therefore, heat and internal energy are definitely not equal. Okay, I can have a very hot object, lots of internal energy, but as long as there's no energy coming in from outside, I don't talk about heat. Alright, I say that the heat is zero, and by that I don't mean that it is cold or that it has no internal energy. When I say the heat in this situation is zero, I just mean that there's no heat energy coming in from the outside or no heat energy going to the outside. So that's how we use heat. So we have to be a little bit careful when we talk about heat in physics from now on. And if an object is really hot, we can say that it has a lot of internal energy, because there's a lot of kinetic plus potential energy. Now, while we are here, this hot and cold object, let's talk about the idea of temperature. The idea of temperature. So if an object is hotter, it has a higher temperature. Object is colder, it has a lower temperature. So heat flows from hot to cold. Okay, we all know that. But when does it stop? Okay. Now it stops when they become equally hot or equally cold. And how do we know when they become equally hot and equally cold? Well, we measure the temperature when the temperature becomes equal. Okay. Now this understanding gives rise to the idea of a law. Okay. Now it seems pretty obvious from our own everyday experience. Okay, but nevertheless, it has been written now as a law. Now it is sometimes called the Zeroth law of thermodynamics. Zeroth law of thermodynamics. And this is what it says. It says that two bodies are in thermal equilibrium, right, when the temperatures are equal. So thermal equilibrium here means that there is no heat flowing from one body to the other. or from the other one to this one. That's the meaning of thermal equilibrium. So let me write this out. Okay. Let me write out this meaning. Thermal equilibrium means this word here, this phrase here means no heat flow. So that's the fancy way of saying no heat flow, right? We like fancy terms in physics. So two bodies are in thermal equilibrium, all right? So in everyday English, we read there's two bodies have no heat flow between them when the temperatures are equal. Pretty obvious from our everyday life, but we call it the Zeroth law of thermodynamics.